Alright, we're going to start our next lesson, 2.5, where we're going to talk about implicit differentiation. So everything we've been doing so far, we've been looking at equations that are in what's called the explicit form. And really all that means is we've been looking at equations that are in the form of y equals some stuff, or f of x equals some stuff. We're going to now look at things that are in what's called implicit form, which instead of them being in y equals something or f of x equals something, it might look like x times y equals some stuff, or it could look like x squared plus y squared equals some stuff. It's really just the x's and the y's are all on the same side. So explicit form, we've solved for y. Implicit form, the x's and y's are on the same side. Some examples. If we had the implicit form, xy equals 1, then its explicit form would be y equals 1 over x, which we know is the same as x to the negative 1, and then the derivative of that is negative x to the negative 2, or negative 1 over x squared. We're going to look at how do we find the derivative without needing to have y by itself. So let's look at our first example. We're going to have a few examples in here. Our first one, we're going to take and find the derivative with respect to x of x cubed. Now this one is fairly simple because we're just going to bring our power down, 3x squared, and that one's done. But maybe in one like b here, we're finding the derivative with respect to x of y cubed. What? But there's no x's there. So what we're going to do, in fact, one way to think of it is here in a, our variables agreed, but in b, our variables disagree. So what we're going to do is we're going to still differentiate it, but we're going to use the chain rule. We're going to think of y to the third as u to the nth power, which when we're finding the derivative of this, we're going to, we know finding the derivative of u to the n is going to be n u to the n minus 1 times u prime. That's what we learned in our chain rule lesson. So we're going to differentiate y to the power of 3 to be 3y squared. And then instead of writing u prime, what we're going to do is write dy dx. But we could also write this in the form 3y squared y prime. And they mean the same thing. So let's look at a couple more examples of how we find the derivative when y is involved. So this is still example 1, but now we're going to look at part C, we want to take the derivative with respect to x of x plus 3y. So when we do that, we take the derivative of the first term, x, that's just going to be 1, plus, when we take the derivative of 3y, we're going to get 3y prime. And then we're done with that. D. Example 1D, we're going to take the derivative with respect to x of x times y squared. We've got a product here. So we're going to take x and then find the derivative with respect to x of y squared, plus we're going to take y squared of the derivative with respect to x of x. So we're going to have x times 2y prime plus y times 1, which means we're going to have 2xy prime plus y. In fact, I forgot to add my power on my y, so these y's should be with powers of 2. I noticed a mistake. So, I've got some guidelines for when we are using implicit differentiation. So, the first thing you're going to do is you're going to differentiate both sides of the equation with respect to x. Once you've done that, then you can collect all the terms with a y prime, or dy dx, if you use that notation. On the left, well, let's not even limit ourselves. On one side of the equation, and all the other terms on the other side. So if you want to put all the y primes on the left, then everything that doesn't have a y prime goes on the right. Once we've done that, our third step is to factor out y prime. And then we are going to solve for y prime. We're going to solve for the dy dx. So let's see an example of how this works. I think we can fit it on this page. So example 2, we're going to find y prime given y cubed plus y squared minus 5y minus x squared equals 4. So we're going to take the derivative of both sides. So we're going to go term by term. Derivative of y cubed is going to be 3y squared y prime plus 2y y prime minus 5y prime minus 2x equals 0. So we took the derivative of everything with respect to x. Now I'm going to move, I've already got all my y prime terms on one side, so I'm going to move everything else to the other. So I'm going to move the 2x to the other side. I'm going to have 3y squared y prime plus 2y y prime minus 5y prime equals 2x. And then I notice on the left side, everything happens to have a y prime. So I'm going to factor y prime out and have 3y squared plus 2y minus 5 equals 2x. And then to solve for y prime, I'm just going to divide both sides. In fact, I'm going to make a little space over here. I'm going to divide both sides by 3y squared plus 2y minus 5 to get y prime equals 2x divided by 3y squared plus 2y minus 5. And that's our answer. That's the derivative of y cubed plus y squared minus 5y minus x squared equals 4 when we solved it implicitly. Let's try another example. So example 3, we're going to find the derivative of x squared plus 4y squared equals 4. Now to do that, we're going to find the derivative of each term. So derivative of x squared is 2x plus derivative of 4y squared with respect to x. Remember, this is all with respect to x. We're going to get 8y prime equals 0 because 4 is a constant. So now I'm going to move my 2x to the other side. So I'm going to have 8y prime equals negative 2x. And then I only have the one term with the y prime, so I'm going to divide by 8y. Y prime is going to be negative 2x over 8y, which we can simplify. So y prime is going to end up being negative x over 4y. And that's all we need to do. So let's look at another example. Let's just keep checking out different examples. Example 4, we're going to find the derivative of 3 times the quantity x squared plus y squared equals 100 xy. Whoa. So, let's find the derivative of this. We're going to first bring down our 2. Well, we're going to differentiate first the left side. So we're going to end up with 6 times x squared plus y squared. Then we have to find the derivative of what's in the parentheses. So we're going to multiply by 2x plus 2y y prime equals 100 times, we've got a little product going here, so we're going to have x times y prime plus y times 1. So let's clean up what we've got. In fact, by clean up what we've got, I'm going to distribute the 6 and the x squared plus y squared on the left to the 2x plus 2y prime. So we're going to end up with 12x times x squared plus y squared plus 12y prime times x squared plus y squared equals, and then I'm going to distribute the 100 in. So I'm going to have 100 xy prime plus 100 y. Now I'm going to move all the terms that have a y prime to one side and everything else to the other side. And I'm going to go with y prime on the left. So I'm going to have 12y prime times x squared plus y squared minus 100 xy prime equals 100y minus 12x times x squared plus y squared. Now, on the left side, both terms have a y prime, so I'm going to factor that out. I have y prime times 12y times x squared plus y squared minus 100x equals 100y minus 12x times x squared plus y squared. Now I need a little space, so I'm going to copy what I have here at the bottom of my work to the top of the page, just so I can make a little more room for myself. Alright, now I'm going to solve for y prime, so I need to divide everything by 12, well, what I have on the parentheses on the left side. So I'm going to end up with y prime equals 100y minus 12x times x squared plus y squared divided by 12y times x squared plus y squared minus 100x. And I do also notice that every term that's now on the right side of my equation is divisible by 4, so I can simplify it. We're going to end up with y prime equals 25y minus 3x times x squared plus y squared over 3y times x squared plus y squared minus 25x. And there's no simplifying I can do from here, so we have found our derivative. Let's check out another example. We're almost done. So example 5, which might be the last one for this video, and then we'll have 2 more in our next one. We want to find the derivative of sine of y equals x. So we're going to take the derivative of each side with respect to x. Derivative of sine is cosine. So we're going to have cosine y, and we're going to times that by y prime equals the derivative of x with respect to x is just 1. So to solve now for y prime, we're going to just divide by cosine y. So y prime is going to equal 1 over cosine y. And we're done. I think we will do the last 2 examples in another video, so stay tuned for that.